Hello, welcome to today's class that will discuss about block diagram reduction techniques. By this time, you would have understood the meaning and the significance of a system being represented by a block diagram. A simple block diagrammatic representation will be having the system's open loop transfer function represented by G of S. The input is usually represented by R of S, the output by C of S. In case if there is a feedback signal, then you will be having a summer. The status of the output is being fed back to the input side via a feedback loop transfer function usually represented by H of S. This is how you will be generally representing a simple system. Again, I am terming out the important notations here. G of S represents your open loop transfer function, open loop. This is your loop transfer function. This is your input. This is your output. This is your feedback. And here you might have plus minus. If it is plus minus, and the system will be a negative feedback system. If it is a plus plus, it will be a positive feedback system. So this is how any system will be represented by a block diagram. Now, this is for a simple system. Suppose if you are having a complicated system, like in case of a big thermal power plant, where you will be using coal to boil water in a boiler, you will be having a coal conveyor system which is to be controlled. You need to have a proper control on the boiler temperature, pressure, etc. So several such subsystems will be combined together to form an overall system. And in this case, here, unlike if you are having a system where you are having two simple blocks, if it is a thermal power system, it will be having hundreds and thousands of such blocks representing the system. In this case, it becomes necessary to reduce that bigger complicated system with thousands of blocks to a simple one like this, where by reducing the system you will be able to relate the output to the input by obtaining the transfer function. So in order to achieve this simplification, there are some techniques that are available. Basic techniques are block diagram reduction, and one more technique is there, that is signal flow graph, that we will learn it later. Now let us see the rules with which we will be able to achieve this block diagram reduction concept. Let us begin by rule number 1, which is how to combine blocks which are in cascade. Cascaded blocks. Assume you are having one block, the second block. The transfer function is G1 here, G2 here. Let the input be R and the output should be R, G1, G2. Now you are having two number of blocks. My intention is to reduce this block diagram into a simple one, where again the same input should be present, the same output should be present. So the thing that I have to do to obtain this input and output is to just multiply these blocks. I will be multiplying these two blocks, into a single one. So this is rule number one, where I am supposed to reduce two blocks connected in cascade.